Hello all, welcome to the subject of microcontroller. I am Professor Nakshi Pancha from Electronics and Telecommunication Department, Parvatibai, Ganba, Mujhe College of Engineering, Moholi, Pune. So today in this lecture we are going to see about interfacing the temperature sensor to our microcontroller. So in a previous lecture we have seen that interfacing digital to analog converter and how to generate a sine wave and how to write a assembly language program to generate a other waves like a propose and how to generate a triangular wave. So today's this lecture we have to see about how to interface the temperature sensor to our 8051 microcontroller and how to write a assembly language code. So let's begin with the basic introduction of temperature sensor. The temperature sensor is the most measured process variable in the industrial automation. Most commonly, a temperature sensor is used to convert the temperature value to an electrical value. The temperature sensors are key read temperature correctly and control the temperature in the industrial application. Here we are considering the temperature sensor LM34 or precision integrated circuit temperature sensor, whose output voltage is linearly proportional to the temperature. The LM35R precision integrated circuit temperature sensor, whose output voltage is linearly proportional to the Celsius of the temperature. And LM34 bar LM35, those has an advantages over the linear temperature sensor and calibrated in the degrees Kelvin, as user is not required to the subtract a large contact constant voltage from output to obtain and convenient scaling. So the LM35 does not require any external calibration or trimming to provide a typical accuracies of plus or minus, that is 1/4 degree at the room temperature, and plus or minus 3/4 degree Celsius over a full minus 55 to plus 150 degree temperature range. So, at which is rated to operate over minus 25 degrees Celsius to plus 150 degrees Celsius temperature range. Here the figure shows connection for LM35 is very simple, and also the output scale is linear with a change of 10 millivolt per degree Celsius. Let's see how to write a assembly language program. Assume our P1 is our input port and which is connected to the temperature sensor, and write a program to read the temperature and test it for the value 35, sorry, 75, and accordingly to the rest of the result, place the temperature value into the register indicated by the following. See here, I will going to write here. We have to write a code, assembly language program. There is a LM temperature sensor that we should connect to port 1 pin, and which is connected to temperature sensor, and write a program to read the temperature and test it for the value 75. We have to read the temperature and we have to read the temperature and test it for value 75. They have given in a problem. According to the result, place the temperature value into the registers indicated. So according to that, we have to take the paste the that temperature value into the register. If T is equal to temperature is equal to 75, then we have to put A is equal to 75, or if T is less than 75, then what to do? Then R1 should be equal to T. We have to place the value like this. R1 value should contain the value of T, whatever it having, that should be contained. If T is greater than 75, if temperature is greater than the value 75, then what should we do? Then we have to place that value into register R2. So this is our program. We have to, it's our problem, and we have to write the code according to this.